The Pythagorean Theorem is a fundamental concept in geometry. It was invented or discovered by Pythagoras. He was an ancient Greek philosopher, and he found out the Pythagorean Theorem amongst many other important geometric concepts. So if you go to page 178, we have a discovery activity that you need to complete for homework tonight that will be graded tomorrow. So let's begin. It says, draw a triangle with vertices A, B, and C. So let's plot those. We have A, B, and C. Connect our lines. Great. Now, we need to find the length of each side. The length here is 3. I just counted. The length from C to B is 4. I just counted. And then the length from A to B, I have to use the distance formula because it's diagonal. So we have A here and B here. I get the distance equals 5. So the length of AB equals 5. Okay, so I'm done with this one. I found the length of each side. Now, let me write how I found the length of this one here. Distance formula. Okay. So now, part B. Draw a square on top of each side using the sides of the triangles as the sides of your 3 squares. So I'm going to draw a square on here. That is 3 units on each side. Same thing here. Okay? And same thing here. Okay? So I have done this. Now I need to find the area of the 3 squares. Well, I know that it's a square and the length of each side is 4, so the area of this one here will be 16. The area of this one here will be 25, and the area of this one here will be 9. Okay? What is the connection between the areas of the 3 squares? Well, 25 equals 16 plus 9. So if we further broke this down, 5 squared equals 4 squared plus 3 squared. Therefore, the relationship here is that C squared, I knew this was C because it's the longest side, is equal to A squared plus B squared. And this is the relationship or the connection between the areas of the 3 squares. This also happens to be the Pythagorean theorem. Let's try it with circles. So again, we have to draw a triangle with vertices A, B, and C. Okay. All right. Now I need to find the length of each side. So I find the length of CB is 4 because I just counted. The length of AC is 3. I found it because I just counted. And I need to do the distance formula, which we already did before, and it's the same triangle, so I'm just going to use the one we found earlier. AB is equal to 5 from the distance formula. Okay, so we have found the length of each side. Now we need to draw a semicircle. So remember what a semicircle is? Half of a circle. On top of each side, using the sides of the triangles as the sides of your 3 semicircles. So we draw a semicircle here. We draw a semicircle here. And we draw a semicircle here. Okay? Now look at these. We need to find the area of the 3 semicircles. So each semicircle, this length of the side of the triangle is a diameter. So the radius is going to be half of that. So the radius of AB is going to be 2.5. Okay? So know that. The radius of semicircle AB is going to be 2.5. The radius of semicircle AC is going to be, what's half of 3? 1.5. And the radius of semicircle CB is going to be 2. Okay, so we're going to use these radii in order to find the area of the semicircles. So let's start with the green semicircle. The formula for area is area equals pi r squared. However, that's for a circle. We're dealing with semicircles, so we're going to divide it in half. So the area is equal to pi times the radius that we found, which is 2.5 squared over 2. And we get 6.25 pi over 2 is equal to 3.125 pi. So the area of this semicircle here is 3.125 pi. Let's do it with the orange semicircle. I'm going to do it over here for some room, okay? Area equals pi r squared over 2 of a semicircle. Let's use the radius that we found of CB, which is 2. So we have area equals pi. Area equals 4 pi over 2 equals 2 pi. Area equals 2 pi. So the area of this here, the semicircle here, is 2 pi. Let's do the other one. Area equals pi r squared over 2. We found the radius of this small circle here to be 1.5. So we're going to use that as our radius. 1.5 squared gives me, and then I get area equals 1.125 pi. So the area of this semicircle here is 1.125 pi. So we need to find the connection between the areas of the 3 semicircles. So just like we found with the squares in the last one, the area of semicircle A plus the area of semicircle B is equal to the area of semicircle C. If we break this down further, we get 2.5 squared times pi plus, oh wait, ignore this part down here. We see that the area the area of the small semicircle, so the area of A, plus the area of the medium semicircle is equal to the area of the big semicircle. So what is the conclusion from problems 1 and 2? Write the Pythagorean theorem and its converse. So, the conclusion from problem 1 was that c squared equals a squared plus b squared. And the conclusion from problem 2 was that the area of the small semicircle plus the area of the medium semicircle equals the area of the semicircle made by C. And we know that if c squared equals a squared plus b squared, the reverse must be true. A squared plus b squared has to equal c squared. Now the connection in the semicircle problem is a little less obvious, but it is still worth showing you. The main conclusion that we want you to reach from witnessing both of those problems is that a squared plus b squared equals c squared. So when can we use this in real life? In carpentry, right angles are used all the time. We always have to determine whether the measurements of the sides of a triangle create a right angle. Because we're not going to sit there and measure the trusses of a shelf with a protractor. This is 5 inches. We can then use the Pythagorean theorem in order to prove that this is a right angle. And it's really important that shelves are right angles, because if they're not right angles, let's say this shelf is like this, everything on here is going to fall off of it. You put something fragile on here, it's going to fall right off. If it's a right angle, it's going to hold it up. So it's really important if you're building a door, right, that this angle here is a right angle, because the door that you're putting in the door jamb is going to be a right angle, and if this here isn't a right angle, the door's not going to fit. So finding whether a triangle is a right angle or not is very important in carpentry, especially since you're not going to measure the corners of a door with a protractor. So just a little real world advice. So these are the questions that we did in class today. So we know that since the problem is giving us a right angle and we have a missing side length, that we're going to use the Pythagorean theorem. So let's start with the Pythagorean theorem, which is a squared plus b squared equals c squared. So first we have to find c. C is always going to be the side that is across from the right angle. With that being said, c squared in this diagram is x. So let's call this one a and this one b. And remember, it doesn't matter. You can even call this one b and this one a if you want. So let's do it like that then. And we get 37.5 squared plus 20 squared equals x squared. So 37.5 squared gives me 1,406.25. 20 squared gives me 400. I add those both together. I get 1,806.25 equals x squared. In order to undo the exponent, I take the square root of both sides, and I get x equals 42.5. Okay, let's do this next one over here quickly. So we start with our Pythagorean theorem. We find c. Here's the right angle. Here's the side across from it. That is my c. B squared, let's call this b, and let's call this a. Multiply through, we get x squared plus 16 over 49 equals 25 over 49. Rationalize our denominator, and we get 49x squared plus 16 equals 25. Subtract 16 from both sides. 49x squared equals 9. Divided by 49, divided by 49, x squared equals 9 over 49. Take the square root of both sides. I get x equals 3 over 7. X equals 3 over 7. And I'm done.